Hi students, today we're going to do 10.5, which is rationalizing the denominator or the numerator of a fraction. Very often we rationalize the denominator, but occasionally you might be asked to rationalize a numerator. It is the same process. So let's take a look at what it means to rationalize the denominator of a fraction. So rationalizing means to get rid of the radical. So it means to make it a rational number, not a radical number, okay? Something like these guys down here, this 2 over root 5, these guys have radicals in their denominator. And if we wanted to rationalize their denominator, it would be to rewrite the fraction as an equivalent fraction that doesn't have a radical in the denominator. The way we do that to rationalize the denominator is the same way we rewrite our fractions as equivalent fractions. It's by multiplying by a version of 1. We want to pick a version of 1, though, that's going to give our denominators the factors it needs to kind of either complete the square or the cube so that it is no longer a radical, okay? So when we look at our first guy, this 2 over the square root of 5, since this is a square root of 5, we need another square root of 5 to make it a perfect square so that we can get rid of the radical. So here we're going to multiply by this version of 1, that is the square root of 5 over the square root of 5, because that second factor of square root of 5 makes the denominator a perfect square, and then we can get rid of that square root. Okay. This second example where we have 7 over the cube root of 2, we have a cube root of 2. And since we have a cube root, we need 3 factors of 2. We need 3 factors of the cube root of 2. We only have 1 of them. So we need 2 more factors of 2. And 2 times 2 is 4. So we're going to multiply this guy by the cube root of 4 over the cube root of 4. We just have a single factor of 2, so we need 2 more factors of 2 to get 3 factors of 2 so we can evaluate that cube root. All right. Let me show you what this is going to look like after we do that actual multiplication by taking us to the whiteboard. Share my whiteboard. Great. So in our first example, we had that 2 over the square root of 5. And our goal here, remember, is to rationalize our denominator. So we don't want to change our fraction. We just want to rewrite it as an equivalent fraction that just looks a little different. So we're multiplying by this version of 1. And when we multiply straight across, the numerator now becomes 2 root 5, and the denominator is the square root of 5 squared, which we know is really just 5. So in our first example, we start with a 2 over root 5, and we end up with 2 root 5 over 5. All we did was multiply by 1. So we know these are equivalent fractions, but our first fraction does have a radical in the denominator. Our second fraction does not have a radical in the denominator. Okay, so that's how you rationalize the denominator. Let's go to our second example. Our second example was that 7 over the cube root of 2. And we decided that we need 2 more cube roots of 2, or equivalently the cube root of 4, to get rid of this radical in the denominator. And if you want, right, the cube root of 4 is really the cube root of 2 times 2. So if it helps you to look at it like that, that's perfectly fine if you want to write it like that. Okay. Now let's multiply this stuff straight across. So we've got the 7 times the cube root of 4. On the bottom, we've got the cube root of 2 cubed is just going to be a 2. Right. So that is how we rationalize the denominator. We multiply by a very specific version of 1, right? This guy's our version of 1 that we're multiplying by 1, but it rewrites our fraction to an equivalent fraction that does not have a radical in the denominator. All right, guys. So that is rationalizing the denominator. Let's do a couple more examples that I have for you. So our next example is 2 root 16 over the square root of 9x. If we want to rationalize this denominator, it's going to be a lot easier if we first simplify all our square roots, okay? We could jump right into multiplying by square root 9x over square root 9x, but let's simplify first. And that the square root of 16 is 4, 2 times 4 is 8, and in the denominator, the square root of 9 is 3. So we can pull out that 9 to get square root and get a 3, and the x is still stuck inside. Okay. So now when we ask ourselves, what do we need to multiply by to get this square root of x to not be a square root anymore? Well, we just need a second factor of x inside a square root. So we're going to multiply by the square root of x over the square root of x. Right? When we do that, we get 8 root x over 3 times the square root of x times the square root of x. And we know that square root of x times square root of x is square root of x squared, which simplifies to simply a and x. No square roots in the denominator anymore. Our radical is simplified and our fraction is simplified. Sorry, our denominator is rationalized and our fraction is simplified. In case you're tempted, we cannot cancel out the square root of x over this x. Okay, because in the denominator here, we have a factor of x. In the numerator, we essentially have half of the factors of x. That's what that square root means. Okay. So that's simplifying or rationalizing that denominator. Let's do another example. Let's say we've got the cube root of 1/5. We want to rationalize this denominator. So you may ask yourself, well, we just have one cube root. It's not really in the denominator. But this fraction, remember, or this term here is actually equivalent to the cube root of 3 over, sorry, the cube root of 1 over the cube root of 5. So we do indeed have a fraction in the denominator. Okay. Here again, we have the cube roots. So we are going to need 3 factors of square root 5. Cube root of that. Sorry, 3 factors of the cube root of 5 in order to evaluate that cube root. We only have 1 factor of the cube root of 5 right now. So we're going to multiply by the cube root of 5 times 5. Or we could say the cube root of 5 squared, or you could say the cube root of 25. However you want to write it is fine. I'm going to write it as 5 squared so that we can really see we've got a 5 here and 2 more 5s here. So in total, we're going to have 3 5s, and we're cube rooting them. So we are getting just a 5 in the denominator. We need to evaluate that cube root. Now in the numerator, the cube root of 1 is just 1. So we're actually just left with cube root of 25 in the numerator. All right. So remember, you can always use your quotient rule here to split up the numerator and denominator of a fraction inside a radical. And then we're using our product rule here to combine these. And then we actually just evaluate that cube root. We've got a 5. Right. One more example for you guys. We're going to do the cube root of z squared over the cube root of 27x to the 4th. So here, let's simplify first before we try to rationalize this denominator. In the denominator, 27 is actually 3 cubed. So notice that 27 equals 3 cubed. All right, and x to the 4th is actually x cubed times x, right? So we have some perfect factors or some complete cubes inside our cube root that we can pull out and simplify. Our numerator does not. We've just got the cube root of z squared. But in our denominator, the cube root of 27 is 3, and this x to the 4th, 3 factors of x will come out as just 1, and then we're left with an x inside. Okay. So the 27, we took the cube root of it. The x to the 4th, we took the cube root of 3 of those factors of x to get our 3x here, but we still have 1 factor of x that stays inside this guy, which is a cube root, right? It's not a square root, it's a cube root. We need to remember that. So now if we want to rationalize the denominator here, we have a single factor of x inside a cube root. So we are going to need 2 more factors of x inside a cube root to make this a complete cube. So we are going to multiply by the cube root of x squared. Right. Now in our numerator, we've got z squared and an x squared. So our numerator has, let me write it over here, cube root of z squared x squared. And our denominator has a 3x times cube root of 3 factors of x is just going to be x. We could also write that as an x squared. And that guy has been simplified, and we've rationalized the denominator because there are no radicals in our denominator. Okay, guys. So that's rationalizing the denominator with just a single term in the denominator. Let me show you how to rationalize the denominator when we have more than 2 terms. It gets a little bit trickier, but not too bad. And you guys have already seen conjugates. Those are the trick here. So take a look at these guys. These 2 fractions here both have radicals in the denominator, but they have 2 terms in the denominator also, which makes it a lot harder when we try to multiply by something to actually get rid of one of these radicals without putting in a new radical. Okay, so you're going to have to multiply this by something very carefully to get rid of the radicals and not reintroduce new radicals. So the trick to rationalizing the denominator when we have 2 terms is to use the conjugate. A conjugate, they are the sum and the difference of the same 2 terms. So a plus b and a minus b are called conjugates. One is a sum, one is a difference. They are conjugates to each other. Okay. Notice, and we did an example like this in 10.4, that a plus b times a minus b just gives you a squared minus b squared. Go ahead and pause the video, do FOIL on this, multiply this out, and you'll see that those cross terms, the a times negative b and the b times a, those terms are going to cancel out. So this is how conjugates work. Their cross terms cancel out, and so you just get the first term squared minus the second term squared. So if both terms end up becoming squared after we multiply out, then it's this that we want to multiply by to get rid of any kind of square roots in our denominator. So when we look at our first example, 2 over 3 times the square root of 2 plus 4, we want to multiply by the conjugate of 3 root 2 plus 4. So we're going to multiply by 3 root 2 minus 4. And it looks like I've got a tiny typo there. Here we go. The conjugate is going to be the opposite sign. So we're going to multiply by 3 root 2 minus 4 over 3 root 2 minus 4. Because remember, we're just multiplying by a version of 1. A very specific version. When this stuff gets multiplied out, the denominator will no longer have any radicals in it. Okay. In this second example, we do the exact same thing. We're going to multiply by square root of 3 minus 5, and I'll show you after we multiply through, the denominator won't have any radicals in it. So let me do that example for you on the whiteboard. Share my whiteboard. There we go. All right, our first example, the 2 over 3 root 2 plus 4. Since we have two terms, we're going to multiply by the conjugate, 3 root 2 minus 4. And whatever we do to the bottom, we got to do the top because we are really just multiplying by a version of 1. Remember, fractions are grouping symbols, so we really have parentheses everywhere here. So we're going to have to use the distributive property. Don't forget that. All right. So when we do our distributive property, the numerator is just going to be 2 times 3 root 2. So we're going to get 6 root 2, and then 2 times negative 4, so negative 8. In our denominator, 3 root 2 times 3 root 2. And then we've got 3 root 2 times negative 4. So I'm going to say negative 4 times 3 root 2. And then we've got 4 times 3 root 2. So I'm just going to write it below, plus 4 times our 3 root 2. And then we've got our 4 times our negative 4, plus 4 times our negative 4. So those are the 4 terms we're going to end up with. But notice that this 4 times 3 root 2 and this negative 4 times 3 root 2, those two terms are going to cancel out. Okay. And now we've got a 3 root 2 times 3 root 2, which is our first term squared. And we've got a 4 times a negative 4, which is our second term squared. So what do we end up with? Again, our numerator is the 6 root 2 minus 8, and our denominator is 9 times 2, right? Because 3 root 2 squared is going to be 9 times 2 minus 4 times 4, 16, and 9 times 2 is 18. So that's just 2. So we've got 6 root 2 minus 8 over 2. And maybe let me slow down. Our first term comes from right here, 3 root 2 times 3 root 2. The 3 times 3 is 9. The root 2 times root 2 is just 2. So that's where we got that 18, okay? Very last thing we want to do is simplify this fraction. We've got two terms in the numerator, the 6 root 2 and the 8. Both the 6 and the 8 have a factor of 2 in them, and so does the denominator. So let's simplify this fraction. The numerator, we can factor a 2 out of that 6, and we can factor a 2 out of that 8. We have 2 in the denominator. Those 2's can cancel out. So our final answer is 3 root 2 minus 4. That's what this whole thing simplifies to after we rationalize the denominator and simplify everything.